we make sure that the only 5 visible cards are present into a current row.
Hello curious students. So today I am back with another interview question, and today the interview question which we are going to cover is, let's just say the interviewer asks you that there is a component tree in a React app which has large number of nodes, and rendering that has become a quite a problem for many users. How do you solve this? So we are going to understand how to solve this using an example of an housing society. Now, the first approach which comes to our mind is virtualization, and yes, virtualization can be used to optimize the rendering of large number of nodes in a list. And the second lesser known way in which we can solve this issue is to optimize the context hook. So let's just say there are multiple contexts which are used in our React app. How we can split that global context into smaller context providers so that the overall performance of the app is optimized. So coming to the context example, we are going to understand that using an example of society, let's just say community bulletin board, where there is an electricity supply notices and there is a water supply notices. So where let's just say the billing information or the people who have paid the water supply and electricity bill supply details are shown onto the bulletin board, and we are going to take this example and we are going to understand how to optimize the use context hook using this example. And in terms of virtualization, let's just say in the same housing society there's an internal app, like let's just say we use mygate or no broker road, and there the list of pre-owned items are listed on the app, and let's just say there are almost 1000 items which are listed on the pre-owned item list. And how we can optimize the performance so that only 10 items are shown at a time onto the list using, let's just say, virtualization or windowing technique. So we are going to understand this with a practical example, and let's jump into the actual code and let's try to understand this in detail. So yeah, let's go ahead.
So welcome back to the second part of the video where we actually understand how to optimize React performance using housing society examples with the practical code. So the first example that we have is a context based example which we are going to understand using community bulletin board. So what I mean by that? So there is a community bulletin board like this which can be found out in most of the societies where they post notices, where they post their dues or any outstanding bills that needs to be paid by the society members. So we have a top section here where we have the electricity updates and the water updates, and we can add our own updates like this, and it gets added into the electricity update. The thing is, these two electricity updates and water updates, they are run by single context, and to understand this better, let's jump into the code. So this is the code that we have, and for the top section we have a combined bulletin context which is initialized using a create context from React. And if you don't know about context, it is basically used to prevent prop drilling and to like share the variables across different components in a optimized manner. Now in this case what we have done is we have a DOM elements here where we have a combined bulletin context provider where we have passed some values, and within that we have the top section where we have the electricity display and the input that you see here, and then we have the water display and water input that you see here. Now in this provider we have a context values, and in that context values we have passed this following data. First is the electricity messages that you see in the main app here. So these are the default messages. Then we have the water message as well, which can be seen in the right hand side. Then we have the message handlers which are used to update the messages. And in the combined context value, we have combined all the electricity and water messages and the handlers as well. And this combined context value is been passed into the provider. Similarly, if we go to the display part, the messages are taken from the context value and they are displayed into the user board. And similarly for water as well, we have the message and they are displayed, and we have the handlers to update the values. Now the problem with this approach is whenever any of this single value is updated, the entire board gets re-rendered, and this can cause performance issues if the list is too long. For example, let's just say electricity updates has, let's just say, 50 to 40 to 50 updates, and water updates also has 40 to 50 updates. Then the re-render can become expensive, and the DOM elements update can trigger a lot of unintended side effects. So this is the problem that we have, and this is the problem which the interviewer expects you to solve when they ask you that how do you optimize the performance when the rendered tree has large number of nodes. So in order to solve this problem, what we do is we split the context. So instead of like the combined context, what we can do is we can have electricity context and water context, which are two separate context values, and within that we can pass the values. So if you see in the bottom section also we have the same updates and water updates, But the difference here is instead of like using the same context values, we have split the context provider into two, where the electricity context provider handles only the electricity part and the water context provider only handles the water context part. And in the electricity context and water context values, we have the split values where the electricity messages and handler is in the electricity context value and water messages and handler are in the water context value. So by this what happens is if we update the electricity updates part, then the water updates part is not getting affected and vice versa is also true. And this is actually optimizing the render performance. So the first optimization that we had was to split the context values in such a way that the render performance is optimized. So this is the first way in which we can optimize the render performance for the context values. The second performance, which is quite obvious, is the windowing technique. So let's just say in the same housing society there is a community app in which the residents can upload the pre-owned items like furniture items and stuff, and let's just say there are thousands of items and we need to render them in a list. Now if you render all those 1000 items in a single go in a DOM, then that could greatly impact the browser performance because that entire list is getting rendered, right? So instead of that, what we do is we rendered a virtualized list, and within that what we do is, let's just say there are 4 to 5 DOM elements which are rendered into the browser. Like in this case there are 5 DOM elements, and we keep on updating those DOM elements only. So we don't append or add 1000 values, but we keep on updating these 5 values based on what is available in the viewport, and only those values are shown to the end user. And this technique is called as virtualization. Now I have covered virtualization in detail in my previous videos, so you can understand from that as well. Just to give you a brief context, let me just open the virtualized list. So what we have here is data, a card item which you can see here, and we have the visible items which are currently restricted to 5. So currently we have the row height, which is the height of each card item, which is set to 280, and we have the visible rows count which is set to 5. So basically only 5 DOM elements are visible at any time in the browser. Then we have some mock items which are generated using a for loop, which are generated up to 1000 elements. So we are passing the upper bound as 1000 and we are generating the mock items, and these are the generated items which contain the id, name, description, price and other details. And we have the image urls generated from pixum api, and these 1000 items need to be rendered into a list. Now in order to render them into the list, what we do is we use virtualization to make sure that only the 5 items which needs to be shown into the current viewport are only shown to the end user, and rest of the items are not shown. So initially what we do is in the didmount method or in the initial method, we only take the first 5 items and we show them to the end user. And when our user scrolls through the data, what we do is based on the scroll top position. So let me just open the console. So basically the scroll top position that you see here. So let me refresh and show it from the start. So based on how the scroll top position is, we keep on updating the start index value, and based on the start index value, we make sure that the only 5 visible cards are present into a current row. So the scroll top position value is the scroll position which is present currently into this window, and based on that scroll position, what we do is we calculate the start index. So here if you see in the handle scroll method, the scroll top position will keep on increasing, and we divide it by row height to take the start index, and based on that start index we also calculate the end index by simply adding, let's just say, the visible rows count to the start index, and then we take that start index and end index, and based on those start and end index we set the visible items which is the slice of start index and up to the end index, and we take those 5 values and we show that to the end user. So that is how these DOM elements are getting replaced. So if you click on inspect, let's just say, and if you go to the section where there is text, so currently it is at 6, right? So as I update these values, you will see that the top DOM element now gets changed to 13. So this is possible because of virtualization or windowing technique, and based on this technique the values are getting updated into the DOM. And this is the most straightforward optimization that you can explain to the interviewer when the interviewer asks about how do you optimize the render performance when the component tree is large. And these were the two examples by which we came to understand that okay, This is how we can use the virtualization and the splitting context technique to update the DOM elements properly and in an optimized manner such that the rendering performance is optimized. So this was a quick short demo of how you can use these two techniques to update the values or the DOM elements efficiently and to optimize render performance. So that was it from my end for today. If you found this video useful, then consider liking the video, subscribe to the channel, and provide feedback of how the video went by. And if you want explanation on any concepts that you would like to understand further, then let me know. I can like cover them in my future videos. So comment any topics that you want to be covered in the future videos as well. So that was it from my end for today. Hope you found this tutorial useful and have a nice day ahead and goodbye.